Sorry. So
that's all right.
Let me introduce you.
Yeah.
Emmanuel is going to present DARTS. That's how you orchestrate different computing, and he's from Soleil.
Yeah, so I'm going to present DARTS. It's quite limited, well, it's a small scale tool, which has proven to be very efficient. And I will explain what we've done with it and how it works first. So I'm in a group heading a group doing data reduction and analysis. It's GRADES, Groupe de réduction et d'analyse de données expérimentale de Soleil. It's in the outer skirts of Paris, some kind of 25 kilometers away. And we are about 10 of us, 6 are permanent and 4 are temporary. So it was created two years ago, basically. So in our group, we are doing scientific software. We are providing these tools to help us beamlines to treat the data. That's going too fast. And Soleil is it's a synchrotron like the others. There's a ring. That's it. So among we do provide scientific software, but we also provide packaging to deploy these software, and we help the beamlines to also develop their code. So our tasks, we have a number of actions that have been initiated 2 years ago. One was to get some infrastructure to run, because there was nothing stable that would satisfy the needs from the beamlines. We deployed Jupyter notebooks, and we deployed, we connected software that was handled by all the beamlines, and we gathered that and provided these tools. And we also have auto processing, that is automatic systems that treat the data. This was our group. Now let's come back to DARTS. So DARTS stands for Data Analysis Remote Treatment Service. And it's, in short, it's a system which you can install on any Linux machine. It installs in a few minutes, really. And it provides environments for analyzing data. So it's a virtualization service, and it works on the web. That is, a user does not have to install anything. You can also use a number of machines which work in the network. Suppose GPU. We need GPUs on synchrotron beamlines, and you can share the sessions between different users. It's an open source code, and it's on our GitLab. We also have a package on Debian. So if we look at what a user on the beamline wants, well, they wish to have access to the data, and this is massive data. They can't transfer the data. It's not. It's very complex to put that on a USB key. If we say let's go on a notebook, sometimes they will say I don't know how to code, and this is quite frightening for some of the users. They prefer graphical user interfaces, but some of them also say I don't want user interfaces. I prefer to code. Well, how to match these two different behaviors? Well, one aspect would be to just provide a system that provides both of these. And of course, we want to minimize the maintenance, because once you provide a system, it's quite demanding to maintain the system online, and so we want to minimize everything. So it must be very simple. And if you provide an HPC, a cluster, then it limits a lot the users you will address, because you need to know what is a batch queue, how you will use MPI, and so on. All this, most of the users, they don't care and they don't want to learn about that. So there's a number of solutions that already exist, and these solutions, there's a number, and most of them are based on kind of OpenStack systems. This has been studied at Soleil, but we've been late in providing this infrastructure, which is here. So this is a common effort from EU. But as we have been late in delivering, in the meantime, we have adopted or have tested this system, DARTS. So it's very limited in our group to the manpower. So the system is extremely simple. It was designed, oops, I wanted. So it was designed in a fortnight. So it was very fast. It provides about the same as Visa. I will show a demo. And it fits in about 1,600 lines of code. So it's very small. So basically what you see is an interface where you specify your ID, and then you can optionally define what you want. The number of CPUs, how much memory, if you want a GPU, and you click on create. Then after about 10 seconds, you've got a connect button. You click on that one, and you get an environment you can use as if you would be in the build line. And this is accessible from, well, ideally, it would be accessible from outside. I will show you. So the user does not need to install anything. And you don't have to copy the data on a USB stick. The data is accessible from the environments. So how does it work? Well, there's a script, it's in Perl, old school. There's a form that feeds information to this script. And then you use qemu, which is a virtualization system. We create an instance from a master virtual machine. We display that with VNC, and through a web certifier, we send it to the browser. So it's quite simple. And forward, forward. Okay, so to install that, you just need very simple tools. And this is an Apache HTML server with Perl, qemu, and no VNC to install the package. So we have a package, but the installation by itself is just one line, and installs everything. So it virtually takes a few minutes. There's a number of configurations you can do. This is in a script, and you can specify how you want to identify the users. The best for us is to use an LDAP, but other systems can be used as well. You can distribute the task among different machines. If one is full, then it goes to the others. And you can set how much CPU and memory you want to give to the system. And if you want also to activate GPUs, or even user customization, which allow the user to enter scripts so that they add, for instance, their own software at boot. So what we, once the system is there, you provide virtual environments. These can be some system from ISO, CD-ROMs, some existing virtual machine from anywhere, supports every system in the world. And you can build your own, of course, and supply the system. And we have a script that builds everything in 10 minutes and delivers systems with software in 10 minutes. We also have some specific systems or virtual machines to provide MATLAB or AlphaFold or Fiji specific environments. This is a non-exhaustive list of what we provide. So these machines are filled with everything that is available in open source. This is just a selection of what we provide for all the areas of the data reduction and analysis. Of course, you can't read from the back, but it's a wide set of software. And all of this comes from Debian. And if there are missing software, we push them into Debian, and then this allows to deploy very easily. And this is why we can build complete systems from scratch in 10 minutes. And as I said, we also have a dedicated virtual environment for running AlphaFold with a GPU in the back. And also, of course, Windows 10 for those that require other commercial software like Igor Pro. Okay, and it's currently available on all our beamlines at Soleil. So if we compare to other systems, of course, now Visa is coming in. It has been deployed initially at the ILL. It has been adopted at the SRF. It's also available at DAISY and in other infrastructures. Of course, DARTS is not exactly the same product, not at all, in fact. It's a very small scale software. And if you look at Visa, it's built to be deployed on large infrastructure to provide a lot of computing power. This is not the case for DARTS. DARTS is a small scale solution which deploys in a few minutes. And this way you have an infrastructure for computing, you provide that in a few minutes to everybody, and you provide environments for the users. So if we compare that, we could say that, for instance, well, can we scale DARTS? Of course, Visa can do that very easily. You just add a compute node to the OpenStack, and then you just scale up the resource you give. Well, DARTS can kind of do that because you can put a number of computers in the network, and they will, in a way, distribute the resources. There's no failure strategy. If something breaks, then the resource is not available. That's all. End of the story. Wherever in Visa, there's a kind of complex system that if something breaks, it just uses the other parts of the OpenStack. So it's much more solid, robust than DARTS. However, as I said, DARTS can deploy in a few minutes, which is an advantage compared to Visa, which requires a lot. You first need to build an OpenStack and then install Visa, which has a lot of configuration systems in there. So the complexity of the system for DARTS is very small. It's a single script, just a single configuration file, which is quite different from Visa. So at Soleil, we will adopt Visa. Today, what we can say is that all our VMs can run quite easily on Visa. We have done tests already. And in the future, in the short future, we will move to Visa. But we will probably retain a small resource with DARTS just for fun and to have on our development systems. But for the users, DARTS will be adopted. Okay, so let's make a short demo. Of course, demos already failed. So just for the demo, I've set up at my home a computer, and I will connect to this computer in France, and we'll see if it works. This is just an experiment. Okay, tries to connect, allow. And I'm not sure it's still, is everything shared, or is it also forecast to the Zoom? No? Okay, so how do I do that? New share. Let's try new share. Okay, that's it. Share. So when I click the link, the browser appeared. So I just enter here some ID. I don't have installed an LDAP on my machine. So sorry, it's just a single machine I set up yesterday in the afternoon. Yeah, 5 minutes is all right. I will just put some kind of login. Okay. In principle, you would put your ID and then your password. Okay. And then I've installed two systems which are based on ISOs. There's a Slacks, which is a Debian based, and the Bodhi Linux, which is another system. You can specify how many cores you want. It's a small laptop on my home, so there's 1 to 4, and this is 1 to 4 gigs. What we have at Soleil, we can reach 64 CPUs, and we can reach 500 gigabytes of memory. And then you click on create. So basically, users just come here and they directly click on create. This way, they have the default. Let's see. Well, doesn't work. Too much memory, right? Yeah, it's a small system. Too much memory. I said 1, please, please. There must be I think a session is running already. No, it's not running. Yeah, 2 sessions are running. So it's in France. It's doesn't work like that every day in France, but sometimes. Sessions. I will kill this session which is running, and I will free some resource. Okay, so let's start again. So this time I create a new system. Yeah, it's coming. Yes. So you see, we are assembling a new virtual machine. It's ready. We connect. All right. I like demos. Are there filters on the IPs or something?
Yes.
On the ports. Okay, so it's using port 6001. Is it allowed on the system here? Perhaps not. I'm afraid it won't go through.
Sorry.
Yeah, it's on my system here on this laptop as well. Believe me, it works. Yeah, sorry for PSI. Security.
Welcome to PSI.
Yeah, this is security. So you have, of course, to allow the proxies and the ports to go through, but you only need one port, which is the one which is not allowed here. Okay, one single port. Okay. So in principle, what you should see is in here a nice Linux system with some applications, and you can just work just like at home. Okay, and it runs in a browser. When you end your session, you release the resources, so everybody can share the resources. And if you provide some systems at Soleil, we have something like 300 cores and 2 terabytes of memory, kind of, and 14 GPUs. This is available for the beamlines. Okay, and done. Yeah, it's all right.
Are there any questions?
Question. Yeah. Can two different users from different remote sites connect to the same session?
Yes. This I can show. When you have this page, you have a share button here. If you click on that one, I said, no, it doesn't. Well, in principle, of course, well, you have a dialog that gives you a URL, a link. You can share it via WhatsApp or email or whatever, and then your colleagues will just connect on the same session. But they share the same screen, and they share keyboard and mouse. So you have to agree on rules, not to do everything at the same time. But it's very efficient. You clearly see the same environment.
Other questions? Yes, sir.
How do you access measured data within your systems from the beamlines?
Well, you just have to make sure that there's an NFS mount in the system you launch. So when you boot, you have an NFS mount to the data, and you identify as a user. You have access to the NFS.
There must be a system which keeps track of who has measured what. That just access your data.
Yes, this depends on how the storage system is configured. Usually you have UIDs and GIDs. So if you connect as this user, you have access to your own data. It's not my part of my work. It's another group. So
I just introduced.
yeah.
Another question, please. Yes, please go ahead.
Sorry. How many user groups have you surveyed to see whether you have solved the problem for them or created the problem?
Good question. Everything which is new creates new problems. This is a definition of it. So, well, as a matter of fact, I think, since the group has been created in 2020, we are learning how to use this environments with users. In fact, there are quite a few issues that come back to us. Most users are satisfied with the systems, and often they make use of the system in ways which are extremely innovative. So we have very few bad marks, I would say. So I believe there aren't so many issues. What issues are related to the quality of the network or quality of the storage or open ports like that here. So this is not our job. We rely on the IT services and we get our phone and say, well, what's wrong with it? So often we just, with our environments, we make use of the resources, network and storage and identification as well. Then with this, we push the limits on the storage and on the network. This is true. But the system itself is extremely stable. It was never rebooted. It works extremely stable.
One last question.
Thanks, Emmanuel, for the presentation. I have a question concerning the performances, because we benchmarked most of our software, and most of them are bound to the ability to read the data in an efficient manner. Mm. And you just mentioned that you were mounted over NFS. This means that your whole infrastructure is limited by the NFS mount.
No.
Is this correct? No.
My infrastructure is not limited. It's limited by what you put in the environment. The infrastructure just runs something. It runs an environment. Then how you configure the environment inside then puts some restraints on how you use the existing network and storage and all this.
But can the imager have access, for example, to a GPFS mount or high-speed access to the disk?
Well, qemu, the emulator underneath, is known that you can connect a virtual machine to the PCI directly.
Okay.
So this is how we export. We bring GPUs inside the environments. This is direct, and there is a complete 100% compatibility and 100% efficiency.
Thanks.
Okay, thanks again,
yeah.
Emmanuel.
Okay.
So, let's see.
Press escape. It is that one because it's in the same window. Escape.
Yeah. Ah,
there we go.
You're right.
There.
Control. Oops. If you want, you can try this one.
Jump to the end slide.
Wow.
Sorry, people.
And it was reversed, right?
For those who are paying attention, yes.
So let's welcome Graham from Dasbury, and he's going to talk about dials.
Okay, I used to be at Dasbury. I think my employer recognized them at
Diamond, sorry. See how old I am.
Yes, I am indeed a veteran of Diamond as well. Dasbury and Diamond themselves. Okay, so I talk very fast. If I'm going too fast, do this, okay? Because I appreciate not everybody in the room has their first language as English. Yes, thank you, Nick. Okay. Right, so because I could well run out of time, the first thing I'd like to do is acknowledge the organizations and the people who have contributed to this work. So everybody in the room knows that developing software costs money because we like to do things like eat, live somewhere, have children. These are all expensive. So yes, we have been very lucky. Oh, hey, yes. So we have been very lucky over the years. We get lots of money from various organizations and very kind grant awards and so forth. Wait, the laser pointer advances the slides as well. Okay, good. And then also, over the years, certainly in the world of single crystal rate diffraction, authors of software have been very kind in writing detailed papers on how their software works. And so that means that we start from a very fertile ground rather than an empty field. Okay, over the years, also many people have contributed to the dial of software. Here's a list which is probably out of date because people keep on adding software and so forth. So you can go and have a look at the GitHub repo and see who has contributed. Okay, so this is of interest to people who work in single crystal X-ray diffraction. I will not be offended if you have a 20-minute nap if you are not interested in single crystal X-ray diffraction. However, if you are interested in pixel array detectors and you have to look after them and curate them and look for dead pixels, I will occasionally mention things that may be useful to you. So keep half an ear. Okay, so what am I talking about here? So the idea basically with dials is we wanted to write some new software for doing single crystal X-ray diffraction data processing. We didn't want to write a black box like XDS, like MOSFilm and so forth, because basically everybody who was involved at the beginning of dials was frustrated by black boxes. So what we wanted was actually to put together some software which would allow everybody to get their data processing done, but also people like the people in this room to be able to use and abuse the software in entertaining ways. Or if you're a scientist and you want to develop some new algorithms, or you've got a postdoc who's looking bored and you want to make it do something, you can send them off in their merry way and they can contribute to the software. We started it off with CCTVX, and it's a hodgepodge of C++ and Python. And I think it's fair to say it is not a gold standard in how you develop good quality software, but it is very useful, and there's an awful lot of useful tools in there that may be useful. We did take a lot of inspiration from Star Trek as well, which was actually some very nicely designed software from the prehistory of time, and I realize now that most of the people in the room are younger than Star Trek. So I shall move on. Okay, so the general capabilities of dials are that this is for doing single crystal X-ray diffraction data processing with the minimum of assumptions. The minimal assumptions are along the lines of your detectors are flat. You can have lots of them, but they are not actually curved or spherical or whatever. It is kind of optimized for pixel array detectors, but it really is only useful for single crystal diffraction, where you can have lots of single crystals, but we don't do powder, we don't do small angle scattering, we don't do all the stuff that was being talked about earlier with the easy diffraction stuff. So, as an overview, I was going to start off talking about the automated data processing that is maybe useful if you want to put tools there in place, automated processing for your users. There are some command line scripts that you can do to make your own automated tools if you feel so inclined. There's a few very useful sort of more advanced tools, and ultimately there is Python API. There's also C++ in there as well if you feel really keen, but at that point you'd be asking us not me to you. Okay, so the automatic processing is really the same as all of the other automatic processing. In our case, it is with ZIA2, but basically it takes diffraction pictures, we can run dials or XDS, and we get MTZ files. For those of you who do not know what MTZ files are, it's just basically the reflection intensities and their uncertainties, and then their indices. It does all the decision making on behalf of your users, so you basically put in images and you take out the resulting data. And at Diamond, it is one of the workhorses for doing all of the automated processing in MX and small molecule single crystal diffraction. In the general sense, the way you run it is ZIA2 and here's some data. So you can be less or more specific on how you say, here are the data. It's either a directory full of data, or you can point it at images, or you can point it at subsets of images, or you can point it at lots of different images, and so on and so forth. But generally speaking, you give it the data and it gets on with it. There are some options that may be useful. So if you have a multi-axis goniometer, you can do things like indexing multiple runs at the same time, which can be particularly useful if you're doing, I don't know, like absolute structure work, and you do crazy stuff like measuring with the detector here, then here, then here, and then back here. Obviously, most people don't do that, but actually at Diamond on I-19 we do. There are some other options that you can tweak as well, but for the most part, this is stuff where it's there, it's automated, there is some documentation. So if you want to know about this, just remember there's this ZIA2 thing, there's documentation. Okay. There are some other ZIA2 tools that I will talk about very briefly as well. So there's one called Screen19, which we developed at Diamond to solve the problem of chemical crystallographers using a Pilatus detector. So for those of you who don't know, small molecule crystals occasionally diffract exceedingly well. If you put one of them on an undulated beamline, you get very strong spots. Pilatus detectors do not like strong spots. So what we found is they were used to using CCDs when they were very, very weak, weak